Hello everyone, welcome to this lecture. So in this particular lecture we will learn more about the Fabric blockchain platform, and we will see the basic architecture of Hyperledger Fabric. Then we will have a demo of the Fabric test network. So Fabric comes with the tools of creating a test network for deploying and developing and testing your applications, and we will try installing a sample chain code and execute it and query it also. So the keywords for this particular lecture are Fabric test network, the Fabric chain codes and transactions. So let us start with the overall architecture of Hyperledger Fabric. So Hyperledger Fabric is a very complex project with a lot of components in itself, but a Fabric network has these specific components. These are the important components, as you can see in the diagram. So first let us start with the ledger. So the Hyperledger Fabric ledger, it is a blockchain, and we can say that it is these are different blocks which have transactions, and one block is connected to the previous block with the last block's hash, and all these blocks and specifically the transactions are forming the world state. So what is the world state? It is we can say that the current state of the blockchain or the ledger is the world state. So Fabric blockchain or Fabric ledger has another concept called channels. So in one Fabric network there can actually be multiple ledgers. Okay. So if one Fabric network has 10 participants or 10 organizations participating in it, then a subset of these organizations can actually start their own ledger shared among themselves only, and not shared with the rest of or outside that subset. Suppose organization 1, 2 and 3 want to have a shared ledger among themselves, and they don't want organizations 4 to 10 to take a look at that ledger or have the permission to access that ledger. Then it can, these organizations 1, 2 and 3 can do that by forming channels. So here in this diagram you can see that this ledger can, or this blockchain can have multiple channels, here represented as a blue and red and green colored ledger. So the different ledgers indicating different channels. Now each of these channels will have their own world state also, right? And then let us go to the different components which are there forming the actual blockchain network. So if you consider one participant organization of a Fabric network, then this organization will have a component called a peer. So Fabric peer is a component which is used by each organization to actually participate and interact with the Fabric ledger, the blockchain itself. So the peer is responsible for executing transactions and query the ledger, and also it provides the interface through which the decentralized applications can connect to the ledger. So as you can see, the peer also is running different chain codes. So chain codes are smart contracts which are deployed in Hyperledger Fabric, and these peers are providing the interface using which client applications can interact with the Fabric network using the Fabric SDK. So Fabric SDK is the software development kit through which you can write decentralized applications on top of Hyperledger Fabric, and these applications will be interacting with the peer. So if your applications want to execute a smart contract, a chain code, or query a particular chain code, then it has to go through the peer only, right? So apart from that, the peer also is listening for events from the ledger. So if new transactions are getting committed, or there are some specific events which are being emitted by different chain codes, then those events are also generated by the peer, which goes back to the Fabric SDK and to the client application. So apart from this peer and the client applications, there is another component called the MSP, or the membership service provider. Hyperledger Fabric is a permissioned blockchain platform, and each participant in a particular network will have their own identities. But it might happen that suppose there is one network of 3 companies, then in each company there might be different participants from that company. Okay. So, accordingly there has to be different identities for different components within the organization also. So, this local membership service provider is actually providing identities to different components within the own within its own organization. So, suppose if O1 had multiple peers, say here we are seeing one peer, but if there were more peers, peer 1, 2, 3 like that, then the MSP would be issuing different identities for those different participants, so that they can execute transactions independently using their own identity. So, this is the representation of one organization. Similarly, there would be other organizations participating in the network, and then the transactions which are being executed by these organizations are ordered in a particular service which is called orderer. So, orderer takes the transactions from different peers and then orders them and compiles them into a block, which are then committed through the consensus process. So, there are different implementations of Fabric orders. So, what the most popular one or the default one is the Raft implementation of orderers. So, we will be seeing that how we can set up a Fabric network. So, to set up a Fabric network easily, Fabric provides the tools to bring a test network. So, the real network in Hyperledger Fabric real deployment, there would be different organizations, and each organization will maintain different components. So, peers, client applications, and optionally their own orderers and membership service providers. So, as we discussed in the last slide, peers are the basic units which are used by the organizations to interact with the blockchain. Okay. Now, in a test network also we would need to create organization and create these components for them. So, in the test network, the default test network settings which are included in the Fabric distribution, if you start the test network, it will be creating all the organizations in a single system. So, if you run it on your laptop, then it will be creating all the organizations in your laptop separated by Docker containers. So, this particular setup is very useful for testing purposes and development purposes. So, if you want to develop a Fabric application or a Fabric chain code, then you can just start a test network and then deploy your chain codes in that particular network and also run your applications and see how it is working. So, the test network is the default settings include 2 organizations, each having one peer and optionally one certificate authority. So, CA is basically one, you can say, one implementation of the MSP. So, CA issue certificate and credentials to different participants within an organization. So, if you have multiple applications, multiple peers, etc., then the CA can issue credentials for them. The test network will be having only one orderer, and all of these components, the peers and the CAs, the orderers, will be containerized. Okay. So, to start the test network, we have to go through these steps. First, from the last lecture, we saw that we created a directory where we installed the Fabric samples, binaries, as well as Docker images. So, you have to navigate to that particular directory and then go to Fabric samples directory. So, in the Fabric samples directory, you will find that there is a particular directory called test network, and that test network has all the tools, the settings and the configuration files which are required to start your test network of 2 organizations and one order. So, if you just go to the test network directory, you will find that there is one executable called network.sh. You can use this network.sh script to start a fabric test network, stop it, and also it provides you different commands using which you can create channels in a fabric network and also deploy chain codes and then undeploy them, etc. So, let us navigate to the fabric samples directory, cd fabric samples, and if you do ls here, you will see that there is a directory called test network. So, let us enter that directory, and here we have to do you have to run this script network.sh. So, we will do /network.sh up. So, this single command will create all the necessary configuration files and all the necessary cryptographic materials and start the Docker containers to run the network. We can see that these are the containers that have been started. So, just like /network.sh up, you can also do /network.sh down to bring down the network. So, if you have one network which is already running, then you can use the command /network.sh down to stop all the running containers and clean up all the artifacts that had been generated and start from fresh. So, once you have the network running, what you can do is you can monitor and see if the components of the networks are running properly or if there are any errors. So, you can monitor the containers using this particular command docker ps. So, what docker ps does, it lists the running containers in your system. So, when you start the test network, the test network by default starts two different organizations, and in each organization there will be one fabric PR container. So, org 0 will be running one fabric PR and org 1 will be running another fabric PR. Apart from that, there will be a single fabric orderer. Okay. And in real scenarios, the fabric orderer might have different instances and they might be using the Raft consensus protocol among them. But here for the test network purpose, there is only one orderer. And finally, there is another container which you will be noticing, that is a fabric tools container. So, using this fabric tools container, what you can do is easily you access the PRs of different organizations and use those PRs to install chain code, query chain code or execute chain codes. So, let us go ahead and try to see how our fabric network looks like. So, if you do docker space ps, then you can see that these are the different containers which are running. This is the Hyperledger fabric tools and then these are the fabric PRs. Okay. So, and also you can see that there is one orderer which is running, and on the right hand side under the ports column, you can see the different ports that these containers are running on. So, these are the different ports using which you can access the fabric PRs and execute transactions. So, once you have ensured that your test network is running and all the containers are working properly, then you can also go ahead and check what are the logs in those particular containers. So, these fabric modules, the PRs, the orderers as well as the fabric CAs and the fabric tools containers, they are running inside containers. So, if you face any kind of errors, then what you can do is you can go ahead and check the Docker logs. So, the different processes, the fabric PR process or orderer process are outputting logs, and to check out those logs you have to use the command docker logs and see the output. So, to check the log of one container, we can do docker space log space -f. So, the -f is optional. If you want to see the logs continuously, then use this and then copy paste the container ID. So, you can see here that these are the logs of the fabric PR container. So, you can see it is saying starting PR, the version number, and then there are several different logs which have been outputted here. So, it says no active channels passed. So, as we saw that the PR log says that there are no active channels. So, indeed there are no active channels when you start the Fabric test network for the first time. So, the Fabric test network gives you the different peers and the orderers, and they are connected and running. But to get started using this particular network, you need to create at least one channel. So, in Hyperledger Fabric, the ledger is actually different channel. So, for each channel there is one ledger, and to do any kind of transactions, you have to do them in specific channels. So, the first step that we need to do after starting the test network is to create a channel. So, how do we create a channel? You can do it simply by using this network.sh script. So, if you run /network.sh and pass this command create channel, then it actually creates this creates the channel with the name my channel. But if you want to use some other channel name, you can do so by just doing /network.sh space create channel and then passing this option -c and the channel name. Suppose you want the channel name to be nptel channel, then you will just do network.sh space create channel space -c and nptel channel. Fine. So, let us try it out. So, ensure that your network is running, then do /network.sh, then create channel. So, if we start this, then it will create a channel with the name my channel. So, what you can do is you can just run this without any option. So, let me just delete this one. So, /network.sh create channel. So, you see the first line, it is saying that it is creating my channel. The channel's name is my channel, and in the green line you can see this, that my channel has been created, and finally we will get some output like this. So, once you have created one channel, let us say that is the default channel called my channel. What you need to do is you need to install your own smart contract, so that you can execute some transactions. So, unlike in the different cryptocurrency based permissionless networks, where the default transaction or the default type of transaction are transferring some cryptocurrencies from one account to another, here in the Fabric network there is no concept of cryptocurrency inherently. Instead, what we deal with are data which are called assets. So, assets are basically any kind of data which are stored in the Fabric ledger, but usually assets are something which have some monetary value that we want to track. For example, if we are using the Hyperledger Fabric network to manage land registry or land records, then different lands are basically the assets. Or if we want to use the Fabric network to create a network for exchanging cars, then the asset type here are the cars, and these cars have different other properties apart from their own values like owners, their manufacturing date, warranty, etc. So, to install a particular chain code, we will be using this script /network.sh, then this command deploy cc, and we have to pass different options. Okay. So, here this particular chain code that we want to install is asset transfer basic. So, this is a chain code which is provided in the Fabric samples repository. So, when you are installing Fabric samples, then you will be finding that inside the Fabric samples directory it is already present. So, we will install asset transfer basic chain code, and this particular chain code is managing some sample assets and which have an owner and some value. So, you have to give a name to a particular chain code when you are installing it, and also you need to specify the language in which the chain code is implemented. So, if you are using the Go programming language, you can pass -ccl space Go. If it is Java or Node.js, this will change appropriately, and this the name of the chain code that we are installing is passed here -ccn space basic. So, instead of basic, you will be adding, you will be replacing basic with the name that you want to give your chain code. So, while installing, you can give any kind of name. So, this is independent of the name of the chain code program files which are there. Fine. So, the name of the chain code or the name of the project that we are using is asset transfer basic, but the name of the chain code after it is deployed will be basic. So, let us go to the samples directory, fabric samples. So, there you can see asset transfer basic. So, this asset transfer basic project will be used here. So, you can go inside asset transfer basic and take a look at what different files and folders are there. So, you can see that there is a specific Go implementation for it in the directory chain code -go. So, let us look at it. You can just open up a text editor here. We are using VS Code. You can use your editor of your choice. So, we can see that these particular chain codes are written in the Go programming language, but you can use chain codes in other languages such as Java or JS. So, to install these chain codes, we need to take a look at this path. So, we will be copying this path or passing the relative path where this particular chain code source code is located. Let us navigate to the test network directory, and here we will be installing the chain code. So, to install the chain code, this is the particular command /network.sh, then deploy cc, then -ccn, and then the chain code name. We are passing this as my chain code, and the path is the path to the source code as we saw, and then the language is Go. So, once you hit enter, you will see output like this. So, you can see that it is outputting chain code has been packaged, and it is installing it in the channel name my channel with the chain code name my chain code. So, this chain code will be installed separately on each PR. So, if you have two organizations and one PR in each organization, then it will be installed in each of those PRs. So, two instances of the chain code. So, we can see that the chain code has been installed, and it also checks if it is installed properly by querying it multiple times. So, after the chain code has been installed, we will see how we can actually go ahead and invoke a particular chain code which is executing this particular chain code. So, to invoke a chain code, we need to do that through a PR. So, as I said at the beginning of this presentation, that PRs are the units which are used by an organization to interact with the ledger. So, we have to tell, so since this is a particular test network, all the PRs are running in the same computer. So, we need to first decide which PR we want to use to make the transaction, and to do so we need to pass a few environment variables. So, how we will do that? We will be using export command to set these environment variables. So, the first one is fabric config path. For the test network, it will be set to the test network directory. So, one level above the test network directory and the config directory inside it. And so, you can just use this fabric configuration path, and it will work fine for the test network. For other networks, it will be changing. So, to target one organization, suppose here we want to use org1, we need to export a bunch of other environment variables also. Here we can see the core PR TLS enabled is set to true. So, the communication between the PRs and the other components can be encrypted, or we can say that we do not want it to be encrypted. So, ideally if we should be encrypting it, so that it is immune to attacks such as no one can read the messages or man in the middle attack, etc. So, at first you will be exporting this fabric configuration path variable to this $pwd / config directory. Then you will be setting this environment variable core pr tls enable to true and export core pr local MSP ID to org1 MSP. So, the organization 1 has one MSP and the ID of that MSP is org1 MSP. Okay. So, this is fixed by the test network scripts. Then you have to export the TLS root certificate files and the MSP configuration path. Okay, so, since we are configuring it for org1, you can see that under the different directories PR organization we are passing org1.example.com. If you want to use org0 or whatever the name of the org is, you have to change this paths accordingly. And finally, you have to export the address of the PR. So, localhost :7051 is the address in which this particular PR is listening to. So, this is PR0 org1.example.com. So, the one and only PR of org1. So, we will be exporting all the environment variables one by one. So, after exporting these variables, you can check if these are set properly by this using this command echo space $ followed by the variable name. So, we can see that fabric configuration path variable is set properly. So, after the environment variables have been exported, what you can do is you can use this particular command. So, this entire slide is a single command, fine. So, you can use this command to invoke a chain code. So, this might look intimidating, but this command is really simple. Most of the parts you do not need to worry about, and you just need to ensure that the channel name and the chain code name that you want to execute are properly set. And finally, this is the argument or the command that we want to invoke. The function inside the chain code, we are invoking init ledger here, and the arguments list is empty, we are passing an empty list. So, the command is pr chain code invoke, and then we are passing a bunch of other options. So, we are first saying that -o localhost 7050, this is the location of the orderer. So, -o is specifying the orderer, then we are specifying orderer TLS host name override. So, the host name of the orderer, and then we are passing the TLS enabled option and the CA files required for TLS and TLS root certificate files, the PR address and also the TLS, yes, the root certificate files of the other PR. So, there are two PRs in our network. So, this is one PR 7051 port, and the second PR is running in 9051 port, and the two PRs have different TLS root certificate files. So, if you just execute this command, you have to ensure that this name is appropriately set as per the chain code name that you have installed. So, just paste this command. So, here our chain code name is my chain code and everything else is the same. So, we will go ahead and execute it. So, init ledger is the function and it shows that chain code invoke successful. So, after this actually you can see docker ps, and you will notice that there are two more containers which have been added. The first one says dev pr0, and then you can see -my chain code. So, actually the chain code is being run in separate fabric containers now. So, if you face any kind of errors while executing a chain code, you can go ahead and take a look at this docker log of this chain code. You will find that this log will be empty if there are no errors, but if you face some kind of error, then you will be having these error logs here. So you can use docker log space the ID of the chain code container, and it will print out all the error logs. So after the chain code invocation is successful, so we executed init ledger function for this chain code, and we saw that it outputted chain code invocation successful. So we will be using query chain code to view the results. So for querying chain code, the command is even simpler. So pr chain code query, then selecting the channel, my channel, and the name of the chain code. This will be changed to whatever chain code name you are using to deploy it, and then the function that you want to query. So here we are using get all assets. So these functions are actually specific to the chain code that you are trying to use. So in this particular chain code, which is asset transfer basic, get all assets will be printing all the assets which it is storing. Similarly, if you use some other chain codes, then these functions might vary. So we will see how we can query the chain code and also invoke it again, and how it is changing the world state of the ledger. So we will be using pr chain code query, then my channel is the channel name and my chain code is the chain code name. So you can see that it is outputting all these assets which are stored by this particular chain code, since we are calling get all assets function. So if you notice asset 6, then it has the owner called Michael. So there is another function that you can use to query it. So that is read asset. So we are doing read asset 6, and then it will only print this asset 6, and you can see that the owner here is Michael. So we will be invoking a transfer asset function and pass the arguments asset 6 and Christopher. So what it will do, it will change the ownership of the asset from Michael to Christopher. So we can see the chain code invocation is successful. So if we query the same asset again, so you can notice here that it has been changed from Michael to Christopher. So if you do the get all assets query again also, then in that output also you will see that asset 6 has owner Christopher. So in this lecture we saw how we can set up a Fabric test network, and then how we can deploy different chain codes and query them and invoke them. So in the next lecture we will see actually how we can write our own chain codes and how we can write the applications that will be using those chain codes to achieve our business goals. So thank you.